Welcome to the video tutorial on how to enter data into the LCA to Go Webtool for machine tools. Part 2. In this model we use more detailed data and focus on the stages with the biggest environmental impacts identified in the rough assessment to achieve a more detailed and robust environmental profile. The results will enable us to draw the right conclusions and identify the improvement potentials. Detailed assessment. We create a new product and choose the option Detailed Assessment. Stage 1. Materials. We define the main components and the contained materials of the machine tool. The machine tool consists of 9 components: the workpiece holder, the tool holder, the housing, the machine foot, the control cabinet, and 3 predefined supply parts, and the oil mist extractor. The oil mist extractor is not a predefined supplier part, therefore we have to define it in the tool. To enter supplier parts which are not predefined, such as the oil mist collector, we start with entering the transport distance from the manufacturer to our plant. In this case, the distance is 1,000 kilometers. Once the transport distance has been defined, the oil mist extractor will appear in the list of user-defined supply parts, and we add the materials and the processes that are required to produce it. Stage 2. Manufacturing. We add the main manufacturing processes that are used at our own manufacturing plant and the weight of material that is removed in shipping processes such as milling, drilling, and turning, as well as the amount of material that is processed in non-shipping processes such as sheet rolling or wire drawing. Additionally, 1,000 kilowatt-hours manufacturing energy is required to assemble the machine tool. 200 kilowatt-hours overhead energy per machine tool are estimated for air conditioning, lighting, heating the manufacturing line. You can add different manufacturing resources. In this case, 9.3% of the material input is wasted in manufacturing. Stage 3. Distribution. The rough assessment has shown that the distribution stage does not greatly influence the result. No further data collection is necessary. The machine tool is distributed to Sweden by truck. The transport distance is assumed to be 1,000 kilometers. For distribution, the machine tool is packed into 150 kilograms PE foil. Stage 4. Use. As seen in the rough assessment, the use stage is the most important life cycle stage. Inaccuracies will have a huge influence on the result. From measurement according to ISO 14955, we derive that the machine tool needs 30 kilowatts electrical power in processing, 10 kilowatts in ready for operation, and 0.3 kilowatts in standby modes. We enter the correct location and the corresponding electricity grid mix. We add 3 different shift regimes to account for the possible different use scenarios by the customer. In this case, a 1-shift, a 2-shift, and a 3-shift regime. The machine tool needs 1 cubic meter per hour compressed air in the operating state, processing, and 0.5 cubic meters per hour in, ready for operation. Further, the machine tool consumes 0.001 kilograms per hour lubrication oil for lubrication. To derive improvement potentials, the electrical power consumption has to be split up into the different subsystems. Stage 5. End of life. We note the parts that are recycled, incinerated, or disposed of in a landfill. Commonly, the majority of machine tool components are recycled. For each part, we can define an end-of-life scenario. Similar to the rough assessment, the results shows us the cumulative energy demand in the 5 life cycle stages. Having entered much more detailed data, we have a greater depth and level of detail in the results, compared to the rough assessment. Results. Detailed assessment. The results are displayed on 2 tabs. Details and graphic results. Again, we define the data quality of the entered data. Compared to the rough assessment, we have more robust data for the use stage. The major environmental hotspot is the electricity consumption in the use phase, followed by the raw materials used in the material stage. The data used to calculate the environmental loads of these stages is robust. The result can therefore be considered as robust. The first figure shows the breakdown of the cumulative energy demand of the material stage, and the second figure shows a breakdown for the manufacturing stage. The next figure shows the breakdown of the distribution stage, followed by a figure showing the breakdown of the cumulative energy demand in the use stage. It can clearly be seen that most of the impact is in the state processing. The 3 components with the greatest impact are the lubrication pump, the air module supply, and the fluid system. Using the result, we can find improvement measures for the different subsystems. Improvements. The suggested improvement measures are in line with ISO 14955. Improvement measures should first focus on the most relevant components in the most relevant life cycle stages. We hope you enjoyed the tutorial and have fun with the LCA to Go tool.